Okay, so the first example that we have for 10.1, we have two circles that intersect and have a common chord of 24 centimeters long. The centers of the circles are 21 centimeters apart, and the radius of one circle is 13 centimeters. We're looking for the radius of the other circle. So let's just pretend we have the radius of P. I can draw that in as 13. So let's think of P being equidistant from the endpoints of A, B, and also O is equidistant from the endpoints of A, B, because those radii would all be congruent in there. OB, OA, and then AP, BP. So if this is 13, we're trying to find OA. So we know that if we get a right angle here, then this splits our chord in half. So that's 12. So this small segment in here ends up being 5. It's a 5, 12, 13 triangle. If we know OP is 21, and we know that that segment is 5, then what's left over is 16. So this segment in here is 16. If we look at this right triangle formed over here, then we have a 12, 16. So this is 3 times 4. This one's 4 times 4. So x must be 5 times 4. So the radius is 20 centimeters. Okay, so the next example problem we're going to do is something we call a walkabout problem. And we call it that because when we solve this problem, we're going to kind of walk around each piece of these tangent segments, and we're going to solve that way. So the first thing I want to do is we want to find the length of AD, and we're calling AQ x. So I'm going to label that as x. Now this problem told us to label AQ as x. I'm always going to label the tangent segment that's part of the full side that I'm looking for. So if I'm looking for side AD, I'm going to start with x as one of those segments. So if that's true, then if AQ is x, then this segment here also has to be x. Well, if AB is 20, then this segment here is 20 minus x. And that's true for the segment here as well. Now, we've taken care of the 20. So BC is 11. So this segment here is 11 minus the segment above, which is 20 minus x. So be careful distributing your negatives here. This is 11 minus 20 plus x. So this becomes x minus 9. That's true over here as well. Oops, that should say x minus 9. Okay, so now if we know that DC is 14, then again, this segment should be 14 minus x minus 9. Again, careful distributing those negatives. This becomes 14 minus x plus 9, which gives us 23 minus x. So if I finish my walkabout the circle, I have again that this is 23 minus x. So if we look at AD is made up of segment x and segment 23 minus x. So together x plus 23 minus x. Those x's cancel out and AD is just 23. So we never really knew what x stood for, but we used that idea all the way around the circle and we can still find AD.